From the start of human history, we've been trying to make sense of the universe and trying to understand our place within it. But at night, where we can see through and beyond our thin blue daylight to the stars, the wider universe is an enigma, a sight that even today asks more questions than we can answer. Over the centuries, we've made great strides. We've learnt that far from being in the centre of the universe, our tiny planet is just one, orbiting an unexceptional star in the fringes of a very ordinary galaxy, adrift in a universe of billions and billions of other galaxies. Building on the genius of scientists like Newton and Einstein, we can even explain how the universe and space and time itself came into being from nothing. But in the last 50 years, we've realised that the predictions of these otherwise uncontroversial laws don't always match with what we actually see in the universe. Cosmologists have calculated that galaxies are spinning too fast to stay together if Einstein's and Newton's laws are applied to all the stars and gas we can actually see in them.
Some physicists have argued that perhaps the laws of physics themselves need to be changed. Intriguing as this possibility is, there really is no justification whatsoever for such a radical assumption. It seems much more natural to assume simply that most of the mass in the universe just does not shine, that most of the mass in the universe is dark matter. The only way we can understand why galaxies spin so fast without flying apart is by assuming that they're held together by the gravity of mass, which, however, we cannot see. This is the main evidence for the existence of dark matter.
Teams of astronomers are using both Earth and space-based telescopes, building ever more accurate maps of the universe we can see, and looking for the telltale signs of the universe which we can't see.
In the past few years, astrophysicists have managed to make a very detailed inventory of what our universe contains. 25%, about a quarter of the contents of the universe, is invisible matter, dark matter that keeps galaxies in place. About 5% of the universe is what we call ordinary matter. That is the matter made up of the atoms of which us, planets, stars are made of. One of the limitations that frustrates cosmologists the most is our inability to carry out experiments. There's really nothing I would love more than to be able to go out into the cosmos, seated with a new form of dark matter, sit back and watch it evolve. We cannot carry out experiments, but we can do the next best thing. We can recreate in a big supercomputer the evolution of the cosmos. Create virtual universes in a computer.
Particle physicists tell us that just after the Big Bang, the universe had slight fluctuations in an otherwise uniform sea of intense radiation. As the initial radiation cooled, fundamental particles emerged and dark matter was created, amplifying these irregularities and eventually creating filaments of great mass which attracted ordinary matter.
Over the past few years, through a combination of astronomical observations, new theoretical ideas, and computer modeling, we have learned a lot about how our universe works. And yet, fundamental questions remain unanswered. We know the dark matter must be there, but we don't really know what it is made of. We know the dark energy must be there, but we don't know what it is. Answering these fundamental and fascinating questions is one of the most important, pressing, and exciting problems for science in the 21st century.